We are going to discuss basically microcontrollers and microprocessors. So what are they, how they can be used and so on, and what's the difference. So as we discussed in the previous lessons and so on, then that basically we've got embedded system, and the definition of the embedded system basically uses some sort of microprocessor or microcontroller which then basically control things, and the application of it is basically like, for example, washing machine, dishwasher, and so on then. So if you look at it, normally microprocessor, for example, in here, is basically what it has is got a CPU, central processor unit, and basically it's got to have some external memory and external input, output, and so on then. So basically you need to have what is classified as other devices, which is basically called peripherals. So you have a CPU, and then you have peripherals basically then can support the microprocessor or the CPU. However, microcontroller, which is the latest technology and so on, then it has everything basically embedded in it in one IC. So which is basically, it's got input, output, clocks, timers, serial ports, and so on then. So that's the difference between microprocessor and microcontroller. So in all technology, if you actually have a microprocessor, you have to actually purchase a lot of external items or peripherals from the third party and put them together in order to actually make an embedded system. However, with microcontroller, more or less all you need is just one IC and so on then. So then we're going to actually discuss and look at the various items in basically in an embedded system and microcontrollers and so on then. So if you look at the first item is memory unit. So the memory unit is basically is part of the actual microcontrollers and so on then, and is very basically fundamental for storing data. And basically if you look at it, you can actually look at it as drawers that you can actually store data, and then you retrieve data, do some sort of maths with it, and then you store it away and so on then. So the memory unit is basically, this is the block diagram, a simple form of memory unit in here. What you have is basically you've got memory locations, and this memory location is called unique address. So virtually when you actually say, for example, you purchase a memory location or the RAM, which is 2K, that is 2000 times 1024. That's the number of location and memory sizes. So every memory location, as you can see, is unique. So it's got location 0, location 1, location 2, and whatever. And these are basically set up by addresses. So we'll have address bus basically coming from the microprocessor and microcontroller, which then basically address or set up the address of the RAM in order to actually access any individual memory location within the RAM. And then also on the other side in here we have data bus. If you notice, the data bus is bidirectional, so you could actually write data into the RAM or read data from the RAM. However, if you look at the actual address side of it, it's basically unidirectional, which is basically you only set up the address. So once you've actually set up the address, then you can actually read or write the information in here. Now also what you need to do is basically you've got to have some sort of control. If you notice in here, it's got WR. W stroke R is basically is a read a write function. So what that means is that basically you can either read from the actual RAM or write into the RAM location. So this will be basically the control bits you need from the CPU or microcontroller to actually do the job. So if you look at the central processor unit, so then we look at the CPU. So this is the CPU. So the CPU, what it has a number of register. For example, register is basically memory, and it can actually fetch information from RAM and basically do some maths function and then store the information to the basically memory location you have. So if you look at it, you have a CPU. So this one is a basically simplified version of a central processor unit and with 3 registers. So you have CPU in here, you've got the address. So this one is actually, you're recording that one, so you need to actually set up the address. And then what you have in here, you've got data, which is the bus is data bus and the address bus. So the data bus is bidirectional, so you actually read and write information to the RAM or memory devices. And also you have control lines. These control lines are actually used whether you control it and you write to it or you read information from the actual external devices and so on. So this is how CPU, which is at the heart of a microprocessor, microcontroller, can actually access other devices on the system. And they normally uses 2 different buses, is address bus and data bus with some control signals and whatever. So if you look at the bus in here, the buses in here are basically can have 8 bits, 16 bits, or maybe the one we are actually using is 32 bits. So this is the actual bandwidth and the width of the buses which is actually used and so on then. So if, for example, if you want to actually set up an 8-bit bus, is basically the number of location you can access is going to be very limited, because what you have is 2 to the power of 8, that's binary. It will be basically 256 different permutation and address. So for 8 bits, you can actually only access 256 memory location. Normally in binary is basically from 0 to 255. So that's for 8 bits. However, if you actually add another extra bit to your address, you can double it. So for example, from 8 bits, if you actually add another bit, you go to 9 bits, that will basically go from 256 to 512 bytes, basically different memory locations and so on then. So if you actually then add another one, so you can actually go to 10, and that will be 1024, that's about 1K. So that is it. With binary numbers, basically each time you add 1 bit, you basically double your capacity. This is why basically you've got, for example, 16 bits or 32-bit processor, because then it will allow you to access more memory location. Not only that, it will also enable you to read and write that sort of thing, a large amount of information and some whatever. So if you look at, for example, 16-bit, that will be 2 to the power of 16 in binary number. That will be about 65,530 something different value and numbers you can actually get and so on. So the bandwidth is basically depends on the actual bus width, some bus number of bits used. So if you actually then look at this one in here, we've got the CPU. So that's the CPU. This is basically internal register to the CPU, and this is how it's interfaced to the memory. We've got the data bus, which is bidirectional. Then we've got the address bus and the control lines. So the control lines you can actually, for example, read or write. As an example, say for example, if the control line is 1, you're actually reading information from the actual memory location. If it's 0, you're writing the information to the memory locations and so on. So this is how you can actually then see a simple configuration of a CPU with a memory locations and so on then. So you've got address bus and data bus. So the more address bits and data bits you've got, the more data capability you have to actually do it. And that's why the cost of the microprocessor and CPU relates to the number of bits it has. Now, the other thing we'll be looking into now is input-output. Now input output, obviously we looked at the microprocessor, the CPU, and some RAM, memory location. RAM, it could be RAM or it could be ROM, read-only memory, or flash, and so on. Also, we have to have some input output units in order to actually interface the microcontroller to the outside world. And this one, you could actually have other units which basically you can actually use to set up the data, to actually write data, read data, or bidirectionals, and so on. So you can actually use it as input, output, and input, output, and so on. So these are, you could actually get a device, external device, but with the microcontrollers, they've already got input, output, and you actually set and configure all of these one using software. So basically it's got port data register normally, and with the port data register you can actually, if it's set to 1, normally it's an input. If you set it to 0, that will be configured as output. So you've got this one as an input output. Now the other one you have in here, for example, you've got serial communication. So what it is that serial communication is how you can actually interface to the other devices. As an example of serial communication, for example, is USB. USB is very simple. You just plug it in and then you can actually copy stuff, informations, and so on. Then normally, if you want to actually use parallel communication, say for example, you could actually need to use 8 lines, 10 lines, and whatever. It's more costly. It's basically the transmission ratio is lower and big and bulky and whatever. However, if you actually use serial transmission, you only need 3 lines virtually. You basically receive line. That's basically what you do. You receive information, you transmit information, and reference line normally is ground. So basically you use 2 wires to send data in a serial format and receive data in a serial format. So how you actually do the data, sending the data in serial format, is basically in binary number. For example, you pick up a word or a byte, which is 8 bits or 16 bits, and then you basically put 1s and 0s, you shift it one at a time onto the basically transmission. And on the receiver side, it will receive the information one at a time and basically restore it, and it gives it to you and whatever. So serial communication is quite important, and normally some of them are called UART, Universal Asynchronous Receiver Transmitter Unit and whatever. And basically it's normally used as a RS-232, which is basically industry standards, and it's been around since 60s, and a lot of communication in industry and automation uses RS-232. However, it's got some limitation or whatever, and the actual speed of it is not as good as some of the other technology we used recently. Now, so we looked at the actual CPU, we looked at the memory interface. Now we looked at the serial one, input output. The other information that you also normally microcontroller have is timers. So you've got the timers, and the timers are heavily used in all sort of application. For example, for any timing activity you want to do. As an example, if you actually assume microcontroller is used for controlling traffic lights. So if you can see basically the light sequence, which goes, for example, red, green, amber, and so on then, and we've got some basically homework and application that you want to do it. So what you need to do for actually changing the timing and get the timing sequence correctly and whatever, you can actually use this timer. And depends on the microprocessor, they've got different number of timers. So it could be like, for example, we are using PIC32. It's got about 5 timers plus a core timer and so on. So these are the timers that you can actually use them, and depends on some of the microprocessor, they could be 8-bit or 16 bits timer, or maybe 32 bits. So that's timers. And then we have another features basically provided by microprocessor. It's a watchdog. So it's a watchdog is like it monitors the functionality of your microcontroller and whatever. So what it does, basically you can actually provide a pulse by the watchdog timer at, say for example, regular interval every second and so on. Then now if something goes wrong, your program crashes or there's a hardware fault, and if that pulse is not provided at the regular interval, then the watchdog will automatically reset your system. So you get a reboot and restart and so on. Then. So watchdog is a very useful feature to actually have if you want to actually monitor your system activity and so on. Then. Now another one we can actually have a look at it is analog to digital converter. Now obviously what we have is that we have in here microprocessor, microcontroller. They are basically all digital. Microprocessor, microcontroller, they basically function with binary numbers, and all they can see as an input as 1 and 0 and so on. However, we could actually interface it to other sensors and other devices which are not basically digital, they are analog. So it could be like, for example, if you look at the temperature sensor, it could be anything between 0 and 2.5 volts, for example. And different voltages, it actually gives you different temperatures and so on. So what we have is that basically the microcontroller, they've got this A to D, which is basically some of these one you can configure in software and then configure them as analog input. So these are the A to D one. So A to D analog to digital register. So you can actually go to this control register and configure them and set up the conversion. So basically what it does various sampling, and it samples the actual input and basically gives you a value. For example, if you've got an 8-bit analog to digital converter, so if you've got an input come in, for example 8-bit, the maximum combination you can get is between 0 and 255. So that's the reading you can get. Say for example, if it's basically you set it between say for example 5 volts, it's going to be 255, and 0 is going to be, for example, 0 volts, maybe 2.5 volts, it could be about, the reading will be about 128. That's basically, you read it in decimal, but that will be given to you in a binary number or hexadecimal and so on then, which will basically cover it in another lessons and so on then. So to basically summarize the whole lot, this is the basically the full picture of a microcontroller. As you can see, it has a CPU. So we start with the CPU. It has a data bus. So as you can see, the data bus actually goes to all of these devices. So you can actually read and write to these devices. And it's got the address bus. So the address bus, you can actually then basically set up the addresses to any interfaces in here, and then basically controlling read and write and so on then. Also you've got read write command that basically control lines which can actually decide whether you're reading or writing on the bus and so on then. It's got watchdog timer, and it's got the timer as well. So this is basically more or less what is a microcontroller is, and all the main components of a microcontroller. And obviously what you do is that when you write the software, you put your software, the program, when you download it, into the memory location area, and then basically you will start monitoring and testing and so on. And this is basically, for example, your input output. So you can monitor and control your input output, flash an LED, read a switch. That's basically, for example, analog to digital input. You can read basically any analog switches and temperature readings and so on. Serial port is basically you've got anything you want to connect, other devices and whatever. Say for example, you could actually for serial port, and an example is the LCD display, that's liquid crystal display. Because crystal display could be actually quite big and bulky and needs a lot of lines or whatever, so you can actually use one of them and then configure it in serial format and so on. Also, you've got other devices that you could actually use. For example, you could actually use keypad and 7-segment display that using the serial port to actually control it and so on. So these are the other options that you have, which is basically serial port. Basically, it saves you a lot of hardware and wiring or whatever, and basically everything is controlled by 2 lines, input and output, the informations and so on. So these are the basic fundamental of a microcontroller. And if you look at in here, you've got CPU, you've got ROM, which is read-only memory, and this could be flash, for example, in the latest technology that you can actually do it. This is the RAM, random access memory. You've got watchdog, you've got timer. These are the ports. Ports are basically input-output, so they could be configured as input, they could be configured as output. Then you've got analog to digital, so you've got the analog to digital converter, then you've got the serial port and so on. So this is a basic main components of a microcontroller, and you can actually then develop software and use it and so on. So these are all basically itemized in here. A CPU, for example, ranges from 4-bit to 64-bit microprocessor. You've got peripherals such as timers and watchdog. You've got RAM, volatile memory. For example, you can actually use it. That's for using the information and so on, and registers and general registers and so on. Then you've got RAM, EEPROM, E2ROM, or flash memory. You can actually use them. They've got the programming capabilities, and you've got serial input output, basically for connecting everything else. For example, USB is a good example of serial input output. You've got basically a clock. Any microprocessor needs to have a clock. So basically you use a crystal or an IC circuit to actually provide the clock for a microprocessor, so you can actually run it and so on. And you've got the address bus and the data bus, serial bus and data bus to carry the actual informations and so on. Okay, so this is basically the basic fundamental of a microcontroller, and with all the elements of a microcontroller that you actually need and so on. So thank you very much.